Welcome back, everyone. Ready for another deep dive?
Always.
Awesome. Today we're going deep on something that seems pretty basic. File uploads. You know, when you upload a profile picture or share a doc online.
Yeah, happens all the time.
Right. Turns out it's way riskier than most people think. We're talking about file upload vulnerabilities.
And those vulnerabilities, they can be a hacker's dream come true.
Exactly. And our roadmap for this deep dive is a document by Shubham Ruder. He really lays out how hackers exploit these vulnerabilities.
Definitely a must-read for anyone who builds or manages websites.
Absolutely. And one of the things that struck me just going through it is how clever some of these attacks are.
Yeah, hackers are always pushing the boundaries, especially with file uploads. Because websites need to let users upload things, there's always this inherent tension between functionality and security.
Right. Got to keep things user-friendly. So before we get into how these vulnerabilities work, let's talk about the why. What kind of damage are we talking about here?
Oh, the possibilities are pretty terrifying. You've got your classic denial of service attacks where a site gets flooded with traffic and crashes.
Right, those are bad enough.
But it can get much worse. Hackers can use file uploads to execute code on a server. That's called remote code execution.
Yeah, Ruder mentioned that. And then there's cross-site scripting, right, where they inject malicious code that runs in someone else's browser.
Yep. XSS attacks can be really nasty. You click a seemingly harmless link, and suddenly your personal information is being stolen.
So we're talking about data breaches, website defacement, even complete server takeovers.
Exactly, and that's just the tip of the iceberg, which is why file upload vulnerabilities are such a big deal.
Okay, so how does this all work? Ruder starts by talking about something called blacklisting bypass. What is that?
So blacklisting is kind of a first line of defense. Websites try to block uploads of certain file types like .php or .exe, which are often used for executable code.
Okay, makes sense. So you just ban the risky file types. But I'm guessing it's not that simple.
You got it. Hackers, they always find a way around those restrictions.
They always do, don't they?
It's like a game of whack-a-mole. So one thing they do is use unusual extensions, like maybe an extension some systems won't even recognize as dangerous.
Sneaky.
And then there are capitalization tricks. Maybe the server is expecting lowercase .php, but the attacker uploads .php with capital letters. Some systems might not catch that.
So it's all about exploiting those little inconsistencies and oversights.
Exactly. And one of the more ingenious tricks is something called null byte injection.
Null byte injection.
Yeah, so a null byte is a special character that basically acts like a terminator. It tells the system, okay, stop reading here.
I'm seeing where this is going.
Right, so the attacker might add a null byte to the file name, like image.jpg, and then stick some malicious code after that null byte. Some older systems might just read the image.jpg part and completely ignore the rest.
So a file that looks like a harmless image could actually contain a hidden payload.
Precisely, and that's just one example of how blacklisting can be bypassed.
Okay, so if blacklisting is so easy to get around, what about whitelisting? That seems like a more secure approach, right? Only allow specific file types that you know are safe.
Whitelisting is definitely considered stronger, but, and this is a big but, its effectiveness all comes down to how it's implemented.
Gotcha. There's always a catch.
Always. Because if that list of allowed file types isn't super comprehensive, or if there are even tiny loopholes in the validation process, attackers can still find a way in.
And I bet Ruder has some examples of that, right?
Oh, he does. One technique is playing with file extensions to make them look harmless.
Like what? Give me an example.
So picture a file named secret.php.jpg. Now, a system that's just doing a quick scan might just see that .jpg at the end and assume it's safe.
It's an image, right?
Exactly. But a PHP interpreter would still be able to run the code hidden in that file.
So even if the file looks like an image to the system, it could still contain hidden executable code. That's sneaky.
It is. And then there's another method using something called a hex editor.
A hex editor, what's that?
So it's a tool that lets you look at and even change the raw data of a file, and that includes something called magic bytes.
Magic bytes, that sounds cool.
They are actually pretty fascinating. So magic bytes are these unique sequences of bytes, usually at the very beginning of a file, and they act like a file's fingerprint. They tell the system what type of file it is.
So like a JPEG has a specific set of magic bytes, and a PDF has a different set.
Exactly, but here's the thing. Hackers can manipulate those magic bytes. They can make a malicious file look like a harmless one by tweaking those initial bytes.
Whoa. So they could disguise a PHP script as a JPG image just by changing a few bytes at the beginning.
Yep. If the server is relying solely on those magic bytes to check the file type, it could be totally fooled.
That's both amazing and terrifying at the same time. So even whitelisting, which seems like a good idea, isn't a foolproof solution.
Not by itself, no. It's all about layers of security.
Right. So what about looking at the content of the file itself? Not just the name or the extension, but actually checking what's inside. Is that an option?
That's called content-based validation. And yeah, it's generally considered a stronger defense because it goes beyond just looking at the surface.
Okay, so you're actually peeking inside the file. But I have a feeling attackers have found ways around that too.
You would be right. And those techniques are even more devious, as we'll dig into those when we come back. All right, so content-based validation, the idea is instead of just looking at the file extension or the name, you're actually analyzing the content of the file to make sure it matches what you're expecting.
So if I'm uploading what's supposed to be a JPEG image, the system would actually look at the data inside the file to confirm it's a real JPEG, not just a file named something.jpg.
Exactly. And this can be really effective, but like with everything in security, there are ways to bypass it.
Of course there are. Hackers always seem to be one step ahead. So how do they do it? How do they sneak malicious code past content-based validation?
Well, one common method is to hide the malicious code within a file that otherwise looks legitimate.
Okay, so like hiding a virus inside a picture.
You got it. One technique is to prepend a valid file header to the malicious code.
A file header.
Yeah, so remember those magic bytes we talked about? Those are part of the file header. It's basically a set of bytes at the beginning of the file that tells the system, hey, this is a JPEG or this is a GIF or whatever.
Right. So they're basically attaching a fake ID to the malicious code?
Exactly. For example, they might take their malicious code and stick a valid GIF header right in front of it.
So the system sees that GIF89A at the beginning, which is the signature for a GIF file, and it thinks, okay, this is a safe GIF image.
Right. And often the system might only check for that specific header and not analyze the entire file, which means the malicious code that's hidden after the header just slips right through.
Sneaky. So even though it looks like a GIF, it's actually a wolf in sheep's clothing.
A very apt analogy. And then there's this other technique that Reuter mentions called the comment upload file bypass. This one is particularly clever.
Comment upload file bypass. Lay it on me.
So certain image formats like JPEG and PNG allow for comments or metadata to be embedded within the file. Think of it like extra information that's attached to the image but not part of the image itself.
Okay, I think I get it. So they're not actually changing the image itself, they're just adding some extra data to it.
Exactly. And the sneaky part is that some image processing libraries, which are the bits of software that handle these images, might just strip out or ignore these comments. They figure, hey, it's just a comment, it's not important.
But in this case, that unimportant comment could contain malicious code.
Bingo. The attacker hides the malicious code within the comment section of the image file. The validation system sees a perfectly valid image, but that hidden code is still there, lurking in the background. And if the system is vulnerable, that code can potentially be executed later on.
Man, these hackers really think of everything. So even content-based validation, which seems pretty thorough, isn't a foolproof solution.
Nope. Nothing is ever foolproof in cybersecurity. There are always ways to get around these defenses. It's an ongoing arms race.
So what else do attackers have up their sleeves? What other tricks does Reuter talk about?
Oh, he goes into a whole bunch of them. Some we've already touched on, like using double extensions.
Double extensions, like file.php.jpg.php.
Exactly. Sometimes, if a server isn't configured properly, it might just look at that last extension and think, oh, it's a PHP file, I know what to do with that.
And completely miss the .jpg in the middle.
Exactly. So it's all about exploiting how systems parse file names.
And then there are attacks that target specific web server software, right?
Right, like with Apache, which is a very common web server, attackers might use double dot extensions in file names. This can sometimes trick the server into accessing files outside of the allowed directories.
So it's like they're using the file upload as a way to break out of the sandbox that the website is supposed to be running in.
A perfect analogy. It's not just about the file itself, it's about understanding how the web server will interact with that file. And then there are techniques that play with how file names are read and interpreted.
Okay, how do they do that?
Well, they might try using special characters or whitespace in the file name, or they might use Unicode characters to try to reverse the display order of the file name.
Reverse the display order. What does that do?
So some Unicode characters can make text display from right to left instead of the usual left to right.
Ah, so you could have a file name that looks like image.jpg but actually ends with something dangerous like gpj.php just by using those special characters.
You got it. And if the system isn't carefully checking the entire file name, it might fall for it.
Wow, that's devious. So it's not just about the file content, it's also about how the file name itself is structured and interpreted.
Exactly. And they might also manipulate something called the content type header.
The content type header, what's that?
So when you upload a file, there's some information that gets sent along with it, like the file name, the file size, and this content type header. And the content type header is supposed to tell the server what kind of file it is.
Okay, so it's like labeling the package.
Right, but attackers can manipulate this header. They can make a malicious file look like a harmless one by changing the content type to something that the server is expecting.
So it's like putting a fake label on a dangerous package.
Exactly. And then there are attacks that don't even involve uploading malicious code at all.
Really? What do those look like?
Well, one example is a pixel flood attack.
Pixel flood attack. That sounds interesting.
It is. So instead of uploading a small file with hidden code, the attacker uploads a huge image file, maybe something that's several gigabytes in size.
Wow, that's a big image. What does that do?
It overwhelms the server. The server have to process this massive file, which takes up a lot of resources, and it can potentially slow down the website or even crash it.
So it's a denial of service attack, but using a giant image file instead of a flood of network traffic.
Precisely. It's all about finding ways to exploit the system, even if it doesn't involve directly uploading malicious code.
Okay, so we've seen that blacklisting can be bypassed, whitelisting can be tricky. Content-based validation isn't foolproof. It seems like no matter what you do, there's always a way for a determined attacker to get through.
That's the unfortunate reality of cybersecurity, but that doesn't mean we should just give up. There are things we can do to make it much harder for attackers.
Right. So let's switch gears and talk about solutions. What can website developers do to protect themselves and their users from these attacks?
Well, the first step is recognizing that any feature that allows users to upload files is inherently risky.
So treat every file upload as a potential attack vector.
Exactly. And don't rely on just one layer of defense. Think defense in depth. Implement a combination of techniques to make it as hard as possible for an attacker to succeed.
Makes sense. So we know blacklisting and whitelisting alone aren't enough. Rooter talks about validating content and using those magic bytes, but we've also seen that those can be bypassed. What else can developers do?
Well, whitelisting, when done properly, is still a great starting point, but you have to be really thorough.
So don't just rely on the file extension, actually check the structure of the file to make sure it matches what you're expecting.
Exactly. And this is where using specialized libraries or tools for validation can come in handy. These tools can analyze the structure of a file in detail and look for red flags that might indicate that it's not what it claims to be.
So if I upload a file that claims to be a JPEG, these tools can actually look at the bits and bytes to confirm it's a real JPEG, not just a malicious file disguised as one.
Precisely. They can check for things like the correct file headers, the expected data structures, and so on.
So they're like digital detectives looking for clues that something is amiss.
Exactly. And another important step is sanitizing file names.
Sanitizing file names. What does that mean?
So it's all about removing any potentially dangerous characters or sequences from the file name.
Okay, so like if someone tries to upload a file with a really long name or a name that has weird characters in it, you just clean it up and remove anything that looks suspicious.
Exactly. It's like scrubbing the file name clean to prevent any funny business.
I like that. Scrubbing the file name makes it sound a lot less technical. Anything else?
Think about where you're storing those uploaded files. Ideally, you want to store them outside of the web root.
Outside of the web root. What's that?
So the web root is basically the main directory of your website. It's where all the files that make up your website are stored. And if an attacker manages to upload a malicious file, you don't want that file to be directly accessible through a URL.
Okay, that makes sense. So you're basically isolating those uploaded files from the rest of your website.
Exactly. It adds an extra layer of security. Even if an attacker manages to upload something malicious, they can't just execute it directly from the web server.
That's smart. It's like putting the uploaded files in a separate room with a locked door.
A great analogy. And of course, access control is crucial. Make sure that only authorized users have permission to access or modify those uploaded files.
Right. Don't forget about permissions. You don't want just anyone messing around with those files.
Exactly. And finally, never underestimate the importance of keeping your systems and software up to date.
Yeah, that's always good advice.
Because new vulnerabilities are discovered all the time, and vendors release patches to address those vulnerabilities. So staying updated is one of the most effective ways to protect yourself.
It's like basic hygiene, but for your website.
Exactly. So those are some of the key strategies for mitigating file upload vulnerabilities. But it's important to remember that security is an ongoing process.
Right. It's not a one-and-done thing. You have to constantly be evaluating your defenses and looking for ways to improve.
Exactly. And with the creativity of attackers constantly evolving, we need to be just as creative in our defenses.
Well said. This deep dive has been incredibly insightful. File uploads might seem like a mundane part of the web, but they're clearly a critical attack vector.
Absolutely. And as we've seen, the consequences of not taking these vulnerabilities seriously can be severe.
Indeed. So as we wrap up, I want to leave our listeners with a question to ponder. Given how persistent and innovative hackers are, what other security measures do you think we'll need in the future to stay ahead of the curve? Let us know your thoughts in the comments. Until next time, stay curious, stay informed, and stay safe.
We've talked about how attackers exploit these vulnerabilities. Let's flip the script and talk about defense. What can developers do to protect themselves?
Yeah, let's get into the solutions. What does Rooter recommend?
Well, first and foremost, developers got to recognize that any file upload feature is a potential risk.
So don't just assume it's safe because it's a basic feature.
Exactly. And don't rely on just one security measure. Think layers, multiple layers of defense, to make it as hard as possible for an attacker to slip through.
Makes sense. So we've talked about blacklisting and whitelisting and content validation, those magic bytes, but we've also seen how hackers can bypass those. What else can developers do?
Well, whitelisting, if it's done really well, is still a solid starting point, but you can't just go halfway with it.
So don't just rely on file extensions. You got to actually verify the structure and content of the file. Make sure it matches what you're expecting.
Precisely. And for that, there are specialized libraries and tools that can help. They can really dig deep into a file structure and spot any red flags.
So if I upload a file that's supposed to be a JPEG, these tools can analyze it at a really granular level and make sure it's a legit JPEG, not a malicious file disguised as one.
Exactly. They can look for the correct file headers, the expected data structures, all those details.
Like digital detectives for your website.
I like that. And another important step is sanitizing file names.
Sanitizing file names. What does that involve?
Basically, you remove any characters or sequences from the file name that could be used in an exploit.
So if someone tries to upload a file with a super long name or a name with a bunch of weird characters, you just clean it up and remove anything suspicious.
Exactly. It's like giving the file name a good scrub to make sure there's nothing hiding in there.
I like that. Scrubbing the file name makes it sound less intimidating. Any other tips?
Think about where those uploaded files are stored. Ideally, you want to keep them outside of the web root.
Outside the web root. What's the web root?
It's basically the main directory of your website, where all the files that make up your site live. You don't want an uploaded file to be directly accessible through a URL, especially if it turns out to be malicious.
So you're isolating those uploaded files from the rest of the website.
Exactly. It adds a layer of protection. Even if an attacker manages to upload something bad, they can't just execute it directly from the web server.
It's like putting those uploaded files in a vault. Keep them separate and secure.
Another great analogy. And of course, never forget about access controls. Make sure only authorized users can access or modify those uploaded files.
Right. Don't want just anyone poking around in there. Solid advice. Anything else?
One more, and it's super important. Keep your systems and software up to date.
Yeah, that's Security 101, right?
It is, but it's amazing how many people neglect it. New vulnerabilities are discovered all the time, and vendors release patches to fix those vulnerabilities. Staying up to date is one of the simplest but most effective ways to protect yourself.
It's like washing your hands for your website. Basic hygiene.
Exactly. Those are just some of the key strategies. But the big takeaway is that security is an ongoing process.
It's not a set it and forget it thing. You always got to be vigilant.
Exactly. And given how creative attackers are, we need to be just as creative in our defenses.
This deep dive has been eye-opening. File uploads seem so basic, but there are so many security implications.
It's one of those things that often gets overlooked, but as we've seen, the consequences of not taking these vulnerabilities seriously can be huge.
Absolutely. Well, thanks for joining us for another deep dive. We've covered a lot of ground today, from the technical details of how file upload vulnerabilities are exploited to the strategies for mitigating those risks. And I think the biggest takeaway is that security is everyone's responsibility. Whether you're a developer building a website, a sysadmin managing a server, or just a regular user uploading files online, we all need to be aware of these vulnerabilities and take steps to protect ourselves. So stay informed, stay vigilant, and we'll see you next time for another deep dive.